Hello my dears, how are you all? So in the last class we discussed about the double line fault, and see, in the competitive type of examination more questions will be based on the for finding the fault current or the sequence component will be based on that two faults, that is LG fault and LL fault. Okay, LLG fault is actually not that much important. That means questions regarding the LLG fault is not that much seen. Okay, listen. So let's discuss about the double line to ground fault. As the name indicate, my dears, double line to ground mean any two line which is fell into the ground, and this will be the circuit diagram, schematic representation. Okay, and this is nothing but, my dear, the neutral impedance. Okay, the neutral is connected because it's a star connected, so the neutral is connected through via an impedance of Zn, which is grounded. And here also the two lines now, B and C, two phases B and C, which is come in contact, and together it will fell into ground. So what happened, my dears? So IB is nothing but the current which is flowing at the instant of fault. IA equal to 0 means, which is nothing but there will not be any load which is connected initially. That means there will not be any fault current, or in other words you can assume like that. IA, IB, IC is nothing but, my dear, current before fault. Current before fault means normal. There is no load connected. We are assuming for the analysis purpose there is no load connected to the power system. Okay, the terminals of the alternator is open circuit, or the power system doesn't contain any load, so that IA equal to IB equal to IC is equal to 0 before fault, as I already said. Okay, before fault IA equal to IB equal to IC is equal to 0, and VA equal to VB equal to VC, because both are VA VB not equal to VA comma VB comma VC, all are balanced because they are 120 degree out of phase with each other. Okay, and EF is nothing but, my dear, positive sequence of the generator induced EMF, or in other words simply E1, because in alternator I already told you that there is no negative, there is no zero sequence. And you can, I'm asked one question to you already, I put it in my short, why there is no zero sequence or negative sequence in alternator. Okay, that was my question, so please comment your answer. And next, listen, my dear. So what happened when these two lines fell into ground means that IB and IC come together and it will flow through ground, and the continuity will be like this. Okay, so the whole continuity path will be IB plus IC current. It is likely to act as a two parallel lines. Two parallel lines come into contact with the ground, and this will be the flowing path. So whenever, my dears, whenever, I already told you in line to ground fault that whenever there is a ground connection to the fault, that is LG and now LLG, and one more is there, LLLG, that is the symmetrical fault, because now we are dealing with the unsymmetrical fault. That's why. So LG or LLG, of course there will be what, my dear, for a ground connection there will be what, zero sequence component of current. In the LG fault, what was that zero sequence component? IA0 equal to IA1 equal to IA2 equal to IA by 3, where IA is nothing but the fault current, because only one phase was fell into the ground. But now the fault current is not simply IB, or the fault current not simply IC, but together will be the fault current. So definitely there will be, of course, what, a zero sequence component. As I said earlier, that zero sequence component is nothing but the total fault current divided by 3. Now the total fault current is nothing but IF divided by 3. That IF is nothing but, my dear, IB plus IC. This is very, very important relationship in LLG fault. Okay, next, what is this fault current? Simply we know that IB plus IC, but in terms of the sequence, the sequence impedances, what is the value of this IF? IF is nothing but, my dear, EF. EF is nothing but the positive sequence of alternator. Positive sequence induced EMF of my alternator. EF divided by Z1 is nothing but the positive sequence of impedance. My dear, what is this Z1 actually? Okay, what is this Z1 actually? Z1 is nothing but, my dear, VA1 divided by IA1. Positive sequence of voltage divided by positive sequence of current. What is this Z0? VA0 divided by IA0. What is this Z2? A2 divided by IA2. Okay, so this is the positive zero component, and Zn is nothing but neutral impedance. So EF whole divided by Z1 plus Z2 into Z0 plus 3Zn whole divided by, divided by is not only for this, divided by Z2 plus Z0 plus 3Zn. So this is the equation of the fault current in a double line to ground fault. That's all. No equation or any important, these two equations are really important. And one more condition here you can apply. If Zn is equal to infinity, what happen? We already said in the term in double line fault now. What if Zn is equal to 0? What if Zn is equal to infinity? Zn is equal to infinity means what, my dear? There is no connection. There is no earth connection. The star point of the alternator is not earthed. What happened? There is no Zn means there is no. This is black. There is no Zn means this is not there. If this is not there means the continuity will break. The continuity, if the continuous break means there will not a flow of fault current. Simply you can explain that with the diagram. Or in other words, if a Zn is equal to infinity in the numerator, what happens back here? Denominator, right? Something by infinity, what happened? Definitely it will be what? 0. So that way also you can express. Okay? That way also you can express. And one more thing you can doubt that Z2 into 3Zn divided by Z2 plus Z0 plus 3Zn means higher power will be of course in the numerator. Higher power degree, because Z2, if Z2 equal to Zn means it will be Z2 square. Something square by numerator is first degree, denominator is first degree and numerator will be second degree equation. So always the numerator will be higher degree and denominator will be lower degree. Then you can definitely apply that L Hospital's rules. Okay, that's actually the mathematical area, but simply you can study like this. If there is a breakage here, Zn is equal to infinity. Infinity means what? It is an open circuit, that's all. Impedance is impedance. Infinity means there is no connection. Zn is equal to infinity, that's all. If there is no neutral impedance, what happens? There is no continuity of fault current. The fault current will be simply 0. Or from the equations of, you can say like that. In the equation of fault, you can simply say like that. And one more thing, my dear, very important term. If IA0 is equal to IF by 3, if IF is equal to 0 means IA0 also 3. A very beautiful relationship. What is that? If there is no earthing of the star connection of alternator, what happens? There will not be any zero secant component. So a beautiful conclusion we can derive from this analysis is that whenever there is a connection of the fault with the ground and there is a continuity of that fault current with the neutral of the alternator, definitely there will be a zero sequence component of fault current. Otherwise there will not be any zero sequence component. Okay? In the electrical inspectorate exam also we saw the same question. Same question is similar. If you know the concept, you can answer that. Which of the following contains the zero sequence component? Options LL, LLL, LG. That's all. So answer will be LG. Line to ground fault. Then that fault only contains the ground, or in what contact with the ground. That fault only contains the zero sequence component. Okay, so that's all about, my dears, the different types of unsymmetrical faults. Very, very important. So LG fault and NL fault, we more focus. Okay, just a relationship now. These relationships are very useful, and the theory also. Okay, so that's all for the double line to ground. Thank you.